Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now if I focus on this topic, which is numerical solution of equations, there are few things that I need to know. Sometimes they ask the knowledge from circular measure, sometimes it's about differentiation, sometimes it is about integration. Of course, there is always the knowledge of sketches from P1, sketches from P3, and so on. And now I'm focusing on May, June 2025, and there are four variants: variant 31, 32, 33, and the fourth variant is also there in this particular year, that is variant 35. So let's focus on four questions that have been asked. So the very first question that I get started with, that is of May, June 2025, variant 31. It has integration also, and of course then the usual all the stuff related with numerical solution. First of all, they're asking integrate this thing. It's equal to 4 and the limits are 1 and a. Show that the upper limit a satisfies this equation where exp, that is another way of writing exponential. So now this is integration by parts. U is natural log, du is 1 over x dx. dv is 6x dx. Therefore, when we integrate, that is 6x square over 2. That is 3x square. So now we will be following these arrows, and this would be u v minus integral v du, because that is the rule. U dv, that is u v minus integral v and du. So now first of all, when we multiply ln x with this thing, which is 6x square over 2. So that is 3x square, and this one is ln x, that is multiplied. And then we are multiplying 6x square over 2, that is 3x square into 1 over x, and that comes out to be 3x dx after the multiplication. Yes, the negative sign is still there. So now when we integrate 3x, this becomes 3x square over 2. Put it inside a bracket, that's the lower limit, that is the upper limit. So now over here, the upper limit is a. So this is 3a square ln a, and over here we get a square. And then we plug in the lower limit, which is 1. So this is 3 into 1 square ln 1 and this thing. Now the easy part is whenever ln we come across ln of 1, that is 0. So this whole thing becomes 0. Now take care of the positive negative sign. This is 3a square ln a minus 3 over 2a square. This minus negative becomes a positive, equals to 4. So now what did I do? I'm multiplying by 2 throughout. So 4 becomes 8 and this becomes 3 becomes 6. And then you have to look at it again. So if exponential is on this side, that means ln of a is something. So therefore, let's make this ln a the subject. This is 8, this is 3, the difference is 5, this negative 3a square becomes positive, division by 6a square. They have taken the 6 common out. 5 over a square plus 3a square over a square, we get this thing. Therefore, a is this much, and let me just remove this thing. So now a is exp, e raised to power of this whole thing. So this thing is done, this is done and dusted. How many marks is this? Yes, 5 marks, because it was integration and then it was making a the subject of the equation. There were 2 a's, of course. This a was the one related with ln a. Now it says verify by calculation. A lies between 2 and 2.1. So this is a change of sign method, and this is proving that the root exists between 2 values. So what we do is that the very first thing that people forget is that take everything to one side. So either use this equation or use this equation, doesn't make a difference. So I've used the final equation a minus exp 1 over 6, 5 over a square plus 3. And now let me show you the values. So this is 2 over here. I plugged in 2 over here. I plugged in 2 over here. I evaluate it. and then over here I plug in 2.1, I plug in 2.1, I plug in 2.1 over here and evaluate. Since there is a change of sign between the two, so one of them will be positive, one of them will be negative. So f of 2.1 and this one is f of 2 over here. Since there is a change of sign between the two values, therefore we would say root lies between the two values. That is the rule, that is the statement that you should write. So one of them will be positive, the other one will be negative. I don't have a calculator handy at the moment, so you can calculate it later. Use an iterative formula based on the equation in part A. Since A was already the subject, therefore this is the iterative formula. It's of the form xn plus 1 is a function of f of xn. So now over here, this is n plus 1 and this is n over here. Now the initial value is 2. Why did I choose this value? I could have chosen 2, I could have chosen 2.1, I could have chosen 2.05, doesn't make a difference. Anything in between the two. When I plug in 2 over here, this 2 goes over here, I get 2.0306. They are asking to work in 4 decimal places so that the final answer is 2 dp. So over here, it's always a rule, work in 2 level up. So 4 dp, work for 2 dp, work in 4 dp, and so on. So now we are getting A1 is this. When we plug this value again in the same equation, the value is substituted. So we are getting A2 as 2.0180. And then when we plug in 2.0180, we are getting this value. Now, if the values are becoming very close, round it off to the level of accuracy that they require. So this is 2.02. This is 2.02. If two answers are the same, that is where the buck stops. That is where you stop the working. So that is the final answer. Now, some people, they ask this question, what if I plug this value over here, that is A3, and I'll get A4, the answer will converge at this point. Now look at the mark scheme. They have plugged in different values. So one of the option is start with 2, 1 step, 2 step, 3 step, you're getting the answer. It's just by chance, by coincidence. If someone started with 2.05, 1 step, 2 step, 3 step, in 4th step, you're getting the answer. If someone is starting with 2.1, then 1, 2, 3, 4. And look at the fluctuation over here. 2.03, 2.01, 2.02, so that fluctuation happens. 2.05, 2.01, 2.02, 2.01, 2.02, and then you get the answer. 2.1, 1.99, 2.03, 2.01, 2.03. Why this fluctuation happens? That's not part of the syllabus. So therefore, we are not discussing it. So this is the first question. That is May, June 2025, variant 31, the numerical solution. Let's move to the next question. That is this thing. This is a graph-based question. So now this is variant 32. By sketching a suitable pair of graphs, show that the equation x minus 2 modulus. So we draw the line y is equals to x minus 2, and x minus 2 was like this, and this portion of the graph is reflected back up. So if this was negative 2 over here, this will be positive 2. So let me write a positive 2 over here. This is 2 over here. That is the V-shaped graph. Now 2 sine half x. 2 sine half x, the 2 is for the amplitude, sine half x. Half cycle in 360, that is 2 pi. But since we are drawing till pi, so we draw 1/4 of the cycle. So basically, this is half cycle. So therefore, 1/4 of the cycle is like this. Now this is 0, this is pi. That's how it's drawn. So now 3.142. So therefore, when we draw this 3.142 and we draw this much of the graph and this much like this. And how many points of intersection are there? That is only one root. So basically, point of intersection of two graphs is basically the root of equation. So one point of intersection, one root, that is all you have to show. Show by calculation that this root lies between such and such. Yes, a very important thing, that is calculator in radian mode. Whenever we are dealing with trigonometry, whether it's about differentiation, whether it's about integration, whether it's about numerical solution, whether it's about differential equation, in vectors it's your choice. In complex number usually it's radians. And then which other chapter? Yes, of course, in trigonometry they can ask this. They can ask about this in vectors. And 1, 2, 3, 4, 5 and 6 and 7. So all these chapters you have to use this thing. So calculator in radian mode, angle in radians. So basically these two things, they are in radians, 1 and 1.5. So again, take everything to one side of the equation like this and then plug in the values. So now when I plug in 1, I'm getting this positive value over here. When I plug in 1.5, that is 1.5 over here, that is half of 1.5, that's 0.75, we are getting a negative value. Got the idea? So now this is 1 and 1.5, x minus 2. So x is 1 and this is 1.5 minus 1. Of course, it means the same thing, but it should be written properly. So this is 1.5 minus 2. So now over here, let me do the correction. That is 1.5 and this one is 1. So one of the value is positive, one of the value is negative. Again, since there is a change of sign between 1 and 1.5, this is change of sign method. Root lies between the two values. This thing is done. The next one, use the iterative formula with an initial value of 1.03. Now, if they have given us an initial value, we cannot unfollow this instruction. We have to follow it. So the initial value is 1.03. You're plugging 1.03 over here. We are getting this thing again. The working is 4 dp and the final answer is 2 dp. We plug in x2, we get x3, we get x4, we get x5, we get x6. Now this is too much. x7, x8, x9. Now we cannot do nothing because everyone will be starting with this value and it's going up till here. Normally it doesn't go that way. Now look at the value, 1.0255, 1, 2, 3, 4 decimal place. Okay. And we want up till 2 dp. So this is 1.03. This is 1.02. This is 1.02. So therefore, this is rounding off to 1.02. This is rounding off to 1.02. Therefore, the final answer is 1.02. That is the final answer. Now, incorrect starting point, then people will be losing a method mark. Once the convergence is established, ignore subsequent working. And that is the final answer. So this one is May, June 2025, variant 32. So now that was the second question. Now the third one, this is about trigonometry. So now sometimes circular measure, sometimes trigonometry, sometimes differentiation, sometimes integration and so on. So now it says the diagram shows the curve. X lies between 0 and pi by 2. This is 0, this is pi by 2. The curve has a maximum point at M. X is equals to A. Show that tangent of 2A is minus 4A. Yes, it is differentiation and trigonometry or differentiation of trig functions. Basically, that is the rule. And then it's about product rule. If y is equals to uv dy by dx, that is uv prime plus vu prime. So now over here, this one is, let me just double check. This thing, this is u prime. This is v, this is v prime. So v prime is 2 cos 2x. So this is 2 and cos 2x. And then v is sine 2x. That is over here. This one is root x. That is u. And this is 1 over 2 root x. That is u prime. So double check again. So this is u, this is v prime, this is v, this is u prime. There is no need of further simplification. Dy by dx equals to 0. So take it to the other side. That negative sign is there over here. And then cross multiply. So 2 and 2 is 4. Root x, that comes out to be x. Indices, surds. Sine over cos is tan negative tangent 2x, or tangent 2x is negative 4x. I'm writing in the form that they are writing. Since x is equals to a, so therefore it's written in terms of a. So that is quite easily done. This one is done. And now it says show by calculation that the root a lies between 0.9 and 0.95. Calculator in the radian mode, that is a must. And then we have this value which is 0.9 and we are getting it negative. So this is 0.9. When we plug in, we are getting negative. When we plug in 0.95, we are getting it to be positive. Since there is a change of sign between 0.9 and 0.95, therefore root lies between 0.9 and 0.95. That is the statement that you have to write, the change of sign method. Now it says, show that if a sequence of values is given by the iterative formula converges, then it converges to A. Now this is a very nice question. There are two approaches to this. The first approaches, this is the first approach and this is the second approach. Now this, let me write it like this, and over here, this color over here, that is this one. Now what I'm doing in this one is that I'm taking the IT formula, the iterative formula, and I'm converting it to the original equation. Now first of all, what is the original equation? The original equation is this: tangent 2a is equals to negative 4a. So that is the iterative formula. Now when we have the iterative formula, we say that after successive iteration, listen to my words, after successive iterations, that's the name of this process, the input value and the output value becomes the same. So basically whatever the function over here is, this and this cancels out. So therefore if I remove this over here, this is what I'm getting. So therefore I'll say the initial value and the final value is the same. Actually this x and this x becomes the same. And then it's just a matter of simplification, multiply by 2. That is pi minus tan inverse 4x. Take pi to the other side. Remove this negative sign. So this is pi minus 2x. And 4x is tangent of pi minus 2x. And then I have used the addition formula. So tangent of pi minus tangent of 2x, 1 plus tangent pi, tangent 2x, we know that tangent of pi is 0. We know that tangent of pi is 0. So I'm left with a negative tangent 2x at the top and a 1 at the bottom, and that is how I prove it. Got the idea? So now the input and the output becomes the same after successive iteration, So there is no need of writing n plus 1. There is no need of writing n. Usually people find this one to be easier. What if the question is like this, that we have the original equation and then we equate it to the iterative formula. We show that the original equation is tangent 2x is negative 4x, and then negative tangent 2x is 4x. Now this negative tangent 2x, I have written this thing. Now can anybody guess what have I done? Basically, I have used this thing, and that was a slight trick that I have used, and let me write it over here. That thing is this, which is a tangent of 180 degrees minus theta, that is equals to negative tangent theta. 180 is the same thing as pi. So basically over here what I have done is this thing, that this thing is negative, and tangent 2x, that is tangent of pi minus 2x, that is this thing used over here. That is how I got this thing. Okay, I involved the pi over here, otherwise it's difficult to think. And then tangent of this thing equals to 4x, pi minus 2x is tan inverse of 4x. The rest of the steps are easy. X equals to this thing, 1x is the subject. So therefore underneath it I'll write xn plus 1 is pi minus tan inverse of 4xn. So always you would find this one to be the easy version. This one was a bit difficult. Got the idea? So that is done in detail. Use the iterative formula in part C to calculate A correct to 4 decimal places. Again, it's the same rule. Correct to 4 decimal places, give the result of each iteration to 6 decimal places. Now this time they're making us work in 6, final answer in 4. So now when we plug in this value, x is 0.9, we are getting 920872, then 917944, then 918347, then 918292. Now over here, we see that this working is giving me 1, 2, 3, the 4th decimal place, that's 918, 918 and 2. So the final answer, actually my bad, it is 4, not 3. So this is 9183 and then focus on 4, 9182. Then focus on 9. So both of them are rounding off to this thing. So that is the final answer, correct to 4 decimal places. And this is May, June 2025, variant 33. So one more question to go, that is this one. Another graph-based question. This is variant 35. It says, by sketching a suitable pair of graphs, show that the equation sec of 2x is negative 2x negative half has exactly one root in the interval x lies between 0 and pi by 2. So sec of 2x, that's a reciprocal of cosine. 2 cycles in 360. In 180, it would be 1 cycle. In 90 degrees, it would be half a cycle. So that is half a cycle over here. Because actually this one and this one is 1 cycle, correct? So therefore, this and this, that's a half a cycle like this over here. The green one, that is sec 2x. And yes, it's a good idea that we should label it. So the green one is y is equals to sec 2x. The straight line, that is negative 2x negative half. Y is equals to negative 2x negative half. And let me also label the previous one, which I think I forgot. No, that is labeled. That is properly labeled. That is this one, that is that one. Okay. Coming back to this one. So now this thing is labeled, and when we are drawing the line, be realistic. This is negative 2x negative half. Negative 2x means negative slope. Negative half is the y-intercept, and you have to focus over here, show that the equation has one real root. So one point of intersection over here, that is one real root. Show by calculation this root lies between 0.8 and 1.2. Take all the terms on one side. That is very necessary. Without it, don't do it. So now just focus on 0.8. When we plug in 0.8, we get a negative value. The value doesn't make a difference. It's the sign that makes a difference. Plug in 1.2, that is positive over here. Since there is a change of sign between 0.8 and 1.2, therefore root lies between 0.8 and 1.2. This thing is also done. And then again the same thing. Show that if the sequence of values given by the iterative formula converges, then it converges to the root of the equation in part 1. Basically, you can either show that the iterative formula make it equal to the equation, or the equation equal to the iterative formula. So this is IT formula make it equal to equation, or equation make it equal to IT formula. Got the idea? So now over here, the very first thing as usual, remove n plus 1, remove n. So this is what you're getting. Multiply by 2. Cos inverse of this bracket is this. Therefore, cos of this thing 2x is minus 2 over 4x plus 1. Flip, flip. So flipping cos 2x will make it sec 2x, and this is the flipping part, and then make sec 2x the subject. That is the answer. Got the idea? So this is the first thing that is done like this. And let's move to the next one. So the next one is this thing, which is the equation to iterative formula. Equation is sec of 2x is minus 4x minus 1 over 2. Sec 2x is written as 1 over cos 2x. So basically cos 2x is minus 2 over 4x plus 1, minus 2 over 4x plus 1. Therefore 2x is equals to cos inverse of this thing, and that is the answer. So that is the answer right over here. Got the idea? Both were easy in this one, nothing special. Use this iterative formula, calculate the value of this root, correct to 3 decimal places, give the result of each iteration 5 decimal place. The plug-in value is 1.0. It lies between these two values, which is 0.8 and 1.2. So that is the safest bet. We plug in 1.0. We are getting this thing 99116, 99271, 99244, 99249. So therefore these are the values, and then are rounded off to 3 dp. So this is 991, this is the 4th dp. 992, this 7 will make it 3. 99244, this would be 992. And this would be 9924, this is also 2. So therefore the final answer, let me write over here, that is 0.992, double check, that is 3 dp, all good. And that is May, June 2025, variant 35. So that is the video on all the May, June, the 4 questions related to numerical solution. Stay tuned for more content on mathematics with Shahab Yaqub.